Hi, welcome to our first section of matrices, organizing data into matrices. A matrix is a rectangular array of numbers written within brackets. If you take a look at these different examples that we have here, the way that we name and classify matrices is by a capital letter. So for instance, this first example here, we could call that matrix A if we wanted. And it's classified by its dimensions. Okay, so the number of horizontal rows and the number of vertical columns as referred to by the dimensions of the matrix. So for instance, remember rows go left to right, so we count down, and the number of vertical columns go up and down, so we are going to count across. For example here, rows by columns is how we always term it, with the by being just a small x in the middle. Find the dimensions of each of the given matrices. If you notice here, we go rows by columns. So in this case, we have 2 rows, 1, 2, and 3 columns, 1, 2, 3. So this would be called a 2 by 3. On example number 2, we have 1, 2, 3 rows and 1 column. So 3 by 1. On number 3, this would be a 3 by 2. Okay, 3 rows across by 2 columns down. And then 4, this is going to be a 1 by 4. You have 1 row across and then 4 columns down. At any time, if you ever want to back up and watch this video again, fast forward, pause, rewind, you're more than welcome to. A matrix element is each number in a matrix is called a matrix element or element. We identify a matrix element by its position within the matrix. So where we name a matrix with a uppercase, we denote where the element is by using a lowercase. So for example, if you look at this, A23 in our matrix A is 4. It's the element that's in the second row and the third column. What I'm going to ask you to do is identify the following elements of the given matrix. We have matrix D, and we're looking for element D34. So in this case, we would go down 1, 2, 3, okay. And then we would go over 1, 2, 3, 4, which would give us the number 2. For D13, we would stay in the first, and then we would look at our third column. So in this case, negative 24. D21, second row, first column, negative 3. And D24, second row, fourth column, 31. How data is organized in a matrix. Take a look at example number 6. We are going to create a matrix based off of the W's and the X's for wins and losses. 3 students kept track of the games they won and lost in a chess competition. They showed their results in the chart below. This says write a 2 by 3 matrix to represent the data. So we're going to have 1, 2 rows and 1, 2, 3 columns. And we can denote these just simply put as wins and losses. And then we can put the names on top if we want to for Ed, Susie, and Joe. So for instance, Ed had 1, 2, 3, 4, 5 wins and 2 losses. Susie had 1, 2, 3, 4, 5, 6 wins and 1 loss. And Joe had 1, 2, 3 wins and 4 losses. How to add matrices together and subtract them. First off, there is a number one rule that we must only add and subtract matrices with the same elements or same dimensions, adding the corresponding elements in the same position. So if we look, for instance, this first one here, this is a 2 by 3, and we're also adding it to a 2 by 3, therefore they can be added together. We're going to add the same element placement. So for instance, when we look here, we've got a 1 in the first one and a 3 in another one. So 1 plus 3 for the first part, negative 2 plus 9, and 0 minus 3. In the bottom row, we've got 3 minus 9, negative 5 plus 6, and 7 plus 12. Then, of course, we can simplify. 4, 7, negative 3, negative 6, 1, and 19. Try number 8 on your own. Pause the video if you'd like, and then come back. Once you've come back, this is a 3 by 2. And this is also a 3 by 2. Therefore, we can add them together. I'm going to skip that part where I'm showing what exactly I'm doing here. Negative 12 and negative 3, so negative 15. 24 and 1, so 25. Negative 3 and 2, so negative 1. 5 and negative 4, so that's positive 1. Negative 1 and negative 1 is negative 2. And 10 and 5 is 15. With subtraction, we do have to take into consideration the minus sign that's in the middle. So I'm going to show all my work for this one in particular. This will be 6 minus negative 4. Notice how that sign will change. Negative 9 minus 3. 7 minus 0. Negative 2 minus 6. 1 minus 5. And 8 minus 10. So we'll now simplify to 10, negative 12, 7, negative 8, negative 4, negative 2. Equal matrices have the same dimensions, and all corresponding elements are also equal. So for example here, if we wanted to solve for x and y, we note that x plus 8 and 38 are in the same elemental position. Therefore, they are both equal. So x plus 8 is equal to 38. So x is equal to 30. We could also then say negative y is in the same position as 4y minus 10. So negative y is now equal to 4y minus 10. Or 5y, if I move that over, is equal to 10. I move the 10 over. So then y is equal to 2. That's it for these notes. Make sure that you complete the corresponding homework. And if you are a little bit confused at all, please make sure to check out some of the other videos that I might have posted in our resources. Also, too, you can always review this video as well.